Hello everyone, I am Sadashay Kanungo. In the 2022 edition of Google Summer of Code, I contributed at Score Lab. This is a demo video for my project NFT Toolbox. So NFT Toolbox is basically a new NPM package that puts together simplistic implementations for the various functionalities that are required for creating NFTs. Over the course of this program, I have implemented 5 functionalities in the project. Let us dive in and have a look at each of them. The first functionality in NFT Toolbox is to generate image and metadata files representing an NFT collection by superimposing a given set of layer images one over the other in different permutations and combinations. This technique of creating large collections is quite popular and has been used to create various famous collections. Let's have a look at NFT Toolbox in action. We first need a set of layer images. Here in the layers directory, I have taken 5 example layers. The user just imports our package, provides basic details of the collection, and then gives a schema. Schema describes the order in which layers are to be superimposed, the number of images to be created, the size of each image, and other such details. Let's run this script. As you can see, a demo collection folder has been created as we specified in our script. Since the size we specified was 100 images will be created inside this folder. As you can see, the assets folder has 100 images, each created by superimposing one of the layer image. For each image, we have a metadata file, which is exactly in accordance with OpenSea metadata standards. So this was generate functionality. The second functionality is uploading these image and metadata files to a decentralized file storage. While IPFS is the most common platform used, there are others as well. So in NFT Toolbox, I have implemented 5 different platforms which provide this functionality. The first one is NFT Storage, followed by Pinata, Storj, and Infura. These 4 provide pinning services to IPFS. The final one, Arweave, is a different platform in itself. Let's have a look at the implementation. The upload functionality comes in 2 parts. First one is uploading an entire collection to the service. The second one, single NFT. Let us look at the collection upload. First, the user initializes the collection, then initializes the file storage service they want. Users can select any one out of the 5. For this example, let us pick nft.storage. Then the user calls the upload collection method. Let us run this script. So the toolbox is uploading the assets of the package, then the metadata files, and finally returns the CIDs of both these folders back to us. Users can also choose to upload a single NFT at a time. For this, we first create the NFT, then we choose one out of the 5 file storage platforms. This time let us choose storage and then call this single upload function. Let us run the script. the asset and the metadata have been uploaded and the CIDs have been passed on. Smart contracts are the backbone of NFT technology. They are the ones which enable ownership, transactions, and other features in this ecosystem. The next functionality in NFT Toolbox is to programmatically generate smart contracts. I have called this functionality drafting. To implement this functionality, we have used Open Zeppelin contracts, which are essentially a community standard in NFT smart contracts. Their new tool, Open Zeppelin Wizard, provides an interface where simple Boolean values are passed for different configurations that are possible in NFT smart contracts, and it generates Solidity files for these contracts for you. Let us have a look at the implementation. In order to draft a smart contract, user simply initializes a contract. This is simply providing the basic details and then the details of the connection that will be used in connecting to a blockchain network, as we will see in later functionalities. After this, the user simply provides Boolean values for the different configurations possible in ERC 721 and ERC 1155 contract standards. Let us run this script to see how it works. Here, the new contracts directory has been created. Inside it, we have the demo contract smart contract. This is a simple ERC 721 smart contract generated programmatically. Likewise, different configurations of ERC 721 and ERC 1155 can be created. This was the draft functionality. After a smart contract has been created, the next job is to deploy it on a blockchain network. This is our next functionality. To implement it, Ethers.js library has been used. Let us have a look at the implementation. The way to deploy a smart contract is fairly straightforward. One simply initializes, drafts, and then calls the deploy contract method to deploy it. The point to note here is the connection parameter passed in initializing the contract specifies which blockchain network is to be used and the provider and signer details required for this transaction. Let us run this script to see how it goes. So after creating the smart contract, the deploy function compiles it and then deploys it. Finally, after deployment, it will pass on the contract address on the blockchain network. Here we go. This was the deploy functionality. The contract that we just deployed using NFT Toolbox is now visible on the Rinkebi Etherscan website. The next job to do is to interact with this deployed smart contract, which precisely describes our next and last functionality in NFT Toolbox. NFT Toolbox has two methods, read and write, for interacting with deployed smart contracts on supported blockchains. Let us have a look at the implementation. Before we move to the implementation of interaction functionality, there is another way to initialize a smart contract. By passing in the deployed parameter, we can represent an already deployed smart contract on blockchains as an contract object inside NFT Toolbox. Let us make use of this initialization method and interact with this deployed contract. In order to give an example of the interaction functionality, let us call the safe_mint function on this contract. We will first check the balance of this address, then mint a token for it, and then check the balance again. As you can see, the read contract and write contract methods have been used for interacting. Let us run the script and see how it goes. The initial balance was 15. After minting the new token, we wait for the transaction to gain block confirmations and finally give another balance count. As you can see, we just minted a new token on a smart contract deployed on blockchain. This was the interaction functionality. There we go. We have covered all 5 functionalities that are present in NFT Toolbox at the moment. Along with the implementation of these functionalities and tests for them, a documentation has also been created for the project. This documentation was created with the help of Docusaurus. Docusaurus provides a landing page for the project, as you can see on the screen, and here is the documentation. The documentation contains detailed explanations, examples, and user guides for each of the 5 functionalities. Here we come to an end of the demo video. Thank you.